Everyone. So in last class we saw what is data structure. So in this class we'll be seeing what is linked list. First data structure will start. Actually arrays whether you had studied last semester. So in this syllabus you have directly linked list. You're able to hear me clearly, right? Okay. So you'll be seeing something called linked list. Okay. So any idea what is linked list? Last class you remember you saw some video, right? Any idea what is linked list? Yes. Any idea what is linked list? Linked list was a data structure. How it was? You remember we saw application last class. It is for doing the songs. Yes or no? It is for song playlist. How it was? Songs were played one after the other. Yes or no? So we will be studying about that today. Okay. So I think you can see the PPT. So we'll be studying about linked list today. So in today's class, we'll see what is linked list and its basic concept. So linked list is nothing but a linear data structure. So linear data structure means it will be arranged one after the other, okay, and it is free from restrictions which are in array. That is, any linked list will be having something called nodes. Okay? A linked list is collection of nodes. Okay? So what is this nodes is? This is called one node. If it is singly linked list, only two parts will be there. One is information, okay, another is pointer. So this will be data point and next it will be pointer. Okay. It does not store any element in consecutive memory location and does not this allow random access also. So how it will be if it is linked list? This is one node. Okay. Assume two nodes are there or three nodes are there. Okay. So how it will be? Okay. So how it will be? So one after the other you can access if it is linked list. Okay. If it is single linked list, you cannot in array what you do, you would write A of 0 means 0th element, A of 1 is first element, A of 2 is second element, so on. Okay. So it is linear. What is this linked list? It is linear collection of data elements which are logically connected to each other. So it is formed by something called nodes. Okay. They are made up of something called nodes. They are connected to each other. Okay. So the data elements are called nodes. It is a dynamic data structure. This is how we represent the linked list. Okay. So sometimes you will have something called start and end. If you want, start means it will give all the information about the linked list. End means to tell it is over. Okay. So here you will have this nodes like this. Okay. So this is singly linked list. So it will go only one direction. So one is your data and then second this is your pointer. Okay. Pointer to next element, so on. This is also data. Okay. This is pointer. So like this you have your elements. Okay. So as we can see in the figure is not, we have two parts in this linked list. Linked list is made up of something called nodes. Okay. Each node will have two parts. One is data, that is your integer, float, char, anything. and second is pointer. Pointer is pointing to, is the address pointing to next node. Okay. So left part of the node includes simple data. This left part will include simple data. Right part will include this, that is your what is that, address to next node. So here, if you have like this nodes, 1, 2, 3. Okay, so maybe you have 1, 2, 3 data, and this is null. Okay, so last will be null because it will not point to anything. So 1, from 1 you will have address of second, node will have address of third. The last node will be null. Okay, so let's see what is advantage and disadvantage of linked list. So this will help in dynamic data structure. What do you mean by dynamic data structure? Yes, in array it was fixed. If I would write A of 100, so 100 memory location was allocated. Here what will happen? Linked list is collection of node. So I want to store one data, then one node will be created and data will be stored in that. Okay, it will have efficient memory utilization. Okay, and insertion and deletion is easier and efficient because easily whenever you want to insert, you can get a free node and insert, and memory also will be efficient. So remember three things, the three advantage. Dynamic it is, whenever you want you can create. Dynamic memory allocation it follows, it has efficient memory utilization, and it is easier and efficient to insert and delete. Disadvantages, it consumes more space. Okay, why it consumes more space? Can anyone tell why it consumes more space? See, if I want to store 1, 2, 3 in array, what would be there? Just space was there for this data, yes or no? But if it is now for nodes, what we have to do? We have to create two space. Okay, one is for pointer, another is for data. Okay, so you will create like this, 1, okay, then 2, then 3. Okay, searching a particular element in the list is difficult. Okay, but one thing is it consumes more space because whenever I want to store any data, one part has to be stored for the pointer, and also searching a particular element in the list is also difficult because whenever I have to search, how we will traverse, starting from first element I have to go to search. I cannot go randomly. In array it was index. A of 0 means you will go to 0th location. A of 3 means I'll go to third location. Here what will happen? If I want to, maybe 3 elements are there, 3 nodes are there like this, 1, 2, 3. So if I want to go to third node also, I have to traverse from first. Okay, so that is the thing here. Next, we'll see comparison between arrays and linked list. So, this is the comparison. In array, size is fixed. In linked list, it is not fixed. Size is not fixed. Okay. So, in array, it is static. So, if you want to tell 100, the size is fixed. In linked list, it is not fixed. What will happen? Whenever you want a node, you can create it. Okay. And it is necessary to specify the number of elements during the declaration. So if you want 100 elements, 100, 10 means 10. Here it is not necessary. It occupies less memory than a linked list. Okay, that is because what is there? Why it occupies less memory? Yes, why it occupies less memory? Can anyone tell? Because here if you want to store the element, only elements you have to store. Here you have to store the address of other element also. It is like on train, how in train one bogie will be connected to another, yes or no, via chains. Same way your linked list is. So one after the other, it will be connected using the pointers. So space will be more. Okay. So inserting new element at the front is very expensive because existing element need to be shifted. That is, in the front it will be very difficult. In array, assume you have 3 element, 1, 2, 3. I can keep new element at the continuous 4, but I cannot insert at the first. Here in you can insert anywhere because here it will be there like this connection. It is a loose connection like this. So if I want to insert middle, I can bring it. Okay, so I can link it to a new node and then make it point. Deleting also an element from an array is also not possible. Okay, in array, whereas in linked list it is possible. Okay, so I'll show you a video. You'll get a clear understanding of the same. Okay, then we'll see some quiz questions. Can see, right? So this is how new node is created and then we are linking them. Last node will have null at the end. So if you want new node, what is this? 525 is the address. Okay. So what is happening here? See here. This is the start node. At 60 is its address. Second address is 102. Third address is 525. After this, no, what is that? No node is there. So it is null. Okay. So 5 is there. Address of it is 102. So we'll write 102. 37. After this, I want to include 1. What is the address of this? 525. Okay. So anything I want to add, I have to create a new node. Then I have to write the data first. Then where I want to connect, I have to write the address here. Okay. So now they want to add this. Okay. So to add this, I have to write the address of this. And last will be null. Last node will have the address null because after that nothing is there. So like this, are you getting? See here, 42 null we have added. We want to add here means I have to write the address of this node. If I want to add next one more node, see, maybe we want to add here. If you want to delete, you can delete also. Only you have to change the pointers. That is address you have to change. Okay. See now what we have done in the position 2. Okay. So what we are doing, see. We are adding here at the position 2 this node. So what will be the address now here? It will be 320. Okay. And its address will be 525. Okay. So you're getting an idea how linked list will work? Yes? Yes or no? So again, 37. Oh. So only what you have to do, first part will be data. Next, whichever node you want after this, you have to write the address of next node. That is how it works. So now let's see some of the questions and end this. So can you see the question? Can you answer this? A linked list is which one? Sequential, random, both or none? Linked list is linear, yes or no? So it is sequential. A linked list is a linear collection of data elements called, one second. Okay, a linked list is a linear collection of data elements called nodes. True or false? Yes, it is true. An array is a which one? Random access or a sequence? Hmm?
Random.
Anything you can access, no? You need not start from starting only. Then a linked list is a data structure which can be used to implement other data structure. True or false? Yes. Linked list is a data structure which can be used to implement other data structure. True or false? Yes, it is true. Linked list can grow and shrink during runtime. True or false? We can add also element, we can delete also. It is true. A node in a singly linked list can reference the previous node. Can it reference? It can only reference next node. Yes or no? Singly linked list. We cannot go back. In doubly linked list, we can go back. In singly linked list, we cannot. It is false. Which of the following is not a disadvantage of usage of array? Yes?
B, ma'am.
It is also. Only insertion, accessing element at insertion based on position. Okay. Sorry, not a disadvantage it is, no. So means this one only. Next, generally collection of nodes is, which one is this? Collection of nodes. What is defined as collection of nodes? It is linked list. Linked list is generally considered as an example of dash type of memory allocation. Which it will use in this?
Dynamic.
Yes, it is dynamic. Each node contains minimum two fields, one field called data to store the data, another is in a node, two fields will be there. One is data, another is, yes, another is, next will be what? Pointer, no? Pointer to what? Next node. So answer is pointer to a node. So each node will be like this. Just now you saw animation also. So first will be here, maybe location of this is 925. So it will be pointer to this. 925, it will point to this. So we'll see some important questions also on this. Okay. So define linked list, mention different type of linked list. Only you can define different types are singly, doubly and circular linked list. I will be teaching you next class. Explain the representation of linked list in memory with the help of illustration. Okay. So some question, only introduction I have shared this taught you today. Any doubts you have? No means I'll end the class, I'll continue tomorrow.
Ma'am, exam ಯಾವತ್ತು?
That you should ask HOD. Okay. IA I'll take on 19th. Let me check in. Okay. Take care. Bye bye.